I've set up here a system of connected particles, two masses connected by a string that passes over a pulley. When I release this, the heavier mass falls and the lighter mass rises. The heavier mass has a mass of 70 grams and the lighter mass has a mass of 60 grams. The distance that the particles move, or the objects move, is 122 centimetres. The aim of the experiment is to predict the time that it will take for the mass to fall to the floor. The diagram shows the forces on the two masses. This is the heavier mass, which has a weight of 0.07 g and an upward tension T. It will have a downward acceleration A. The lighter mass will have an upward tension T, which will be equal to the tension T here, and a downward weight 0.06 g and an upward acceleration. So considering the left-hand particle as I've drawn it, the resultant force will be T minus 0.06 g, and the resultant force will be equal to the mass times the acceleration, which will be 0.06 a. Now considering the other particle which accelerates downwards, the resultant force will be 0.07 g minus t, and that resultant force will be equal to the mass times the acceleration, 0.07 a. Solving these equations gives the acceleration as 0.75 meters per second squared. Now we can use the equation S equals ut plus a half at squared. S will be the measured distance, 1.22. As the particles are released from rest, u will be 0, so this whole term will be 0, and that will be equal to a half times 0.75 t squared. Solving this equation gives the time as 1.8 seconds. So now to conduct the actual experiment, you may have noticed that the pulley was creaking a bit when I demonstrated this earlier in the video, so I've actually taken the opportunity to put a little bit of oil on the pulley so that we get a better result. Here goes. The time that we have observed from the experiment is slightly greater than the 1.8 seconds. This is to be expected because of two factors. One is the effect of air resistance on the objects as they move, and the second is due to the fact that the pulley is not perfectly smooth and not perfectly light.